Okay, and our other example here is going to be when we have a system of equations that might have an infinite number of solutions to it. So maybe we're going to start off with equations that look like this. So we've got y equals 3x minus 2. And then I've got 15x, that's a 15 it's supposed to be anyway. 15x minus 5y equals 10. Okay, so the first thing you should be able to see is this is not set up correctly. I've got the x's and y's on opposite sides on the top one. However, because the y has a coefficient of 1, it's going to be easier to use substitution here. So I'm not going to reorder this. I am literally just going to take everything here that this thing is, 3x minus 2, that's equivalent to y. I'm going to substitute it in for the y down here, and then we're going to have everything in terms of one variable. So let's do that. So 15x minus 5 times, replace the y with 3x minus 2 equals 10. Okay, let's go ahead and solve this one. So we've got 15x, distribute the negative 5 through. So we've got negative 15x, and then negative 5 times negative 2 is plus 10 equals 10. So what we have on the left-hand side, if I simplify, I've got 15x minus 15x. Well, that's 0. That goes away. So what that leaves me with is a statement that says 10 equals 10. Well, 10 equals 10 is true. It's always true. There's no variables left over. There's nothing for me to solve for. Because I ended up with a true statement, that's a true statement, 10 equals 10, that means that this is always going to work, which tells me that these two lines are the same. These two lines are the same, which means that I have an infinite number of solutions. Please do not confuse that with the solution being infinity. Okay, the solution to this is not infinity, but there are an infinite number of solutions. There's an infinite number of points along both of these lines that are going to be exactly the same thing. So when you get a true statement, it is called consistent because there are solutions, and in this case, because the two things are exactly the same, there are an infinite number of solutions. It is called consistent. Okay, we're going to do one example of an application. So we'll call this one example 7. And this is what is called a break-even point. Break-even point. Okay, and this has to do with cost and revenue and profit. So if you're talking about profit, the profit that you make on something, the profit is defined to be how much you may bring in, which is called the revenue, minus how much it costs you for supplies or whatever it is that you have to do to start this thing. So your profit is how much you actually make off of something minus how much you had to spend to do it. That's the cost. So the break-even point is when your profit is 0. Basically, you have spent the exact same amount of money that you have made, so you haven't made anything, but you haven't lost anything either. So the idea is the break-even point is when the revenue equals the cost. So if you have the revenue and the cost function, and you want to find the break-even point, you set those two things equal to each other, and you solve. So in our circumstance here, we are going to be given a cost equation, or we may have to actually create the cost equation. In our case, our cost equation is going to be $500,000 plus 400x. Now, whatever x represents, x could be the number of cups that you have to buy, or chairs, or desks, or something like that. And what that's telling you is it's going to cost you $500,000 to start. Okay, that's the fixed cost. This is fixed. But then it's also going to cost you another $400 to purchase these items. So it might be $400 per chair, or something like this. So this right here is like, it's like per unit of whatever it is that you're buying. And then the X part itself, that's the number of units. So again, X could represent like the number of chairs or something. So what this might be saying is it's going to cost you $400 per chair. So 400 times X, $400 per chair. And it's going to cost you $500 initially just to start up the business or start up this thing anyway. And then we're going to be having the revenue, which says that, okay, well, it's costing me $400 per chair, so I need to make some money. I'm going to have to up the price because otherwise it's going to take forever for me to, actually I'm not going to make anything if I make it exactly $400. So let's say that we're going to sell each chair or whatever it is for $600. So 600 times X would be the revenue. So every time I sell one, now I'm going to make $600 off the chair. The idea is we want to find out what the break-even point is. How many of these chairs am I going to have to sell before I get back everything that I've spent out? So the idea is set cost and revenue equal to each other. So we're going to set 500,000 plus 400x equal to 600x. And now we're going to be able to figure out how much money it's going to take, how many chairs we're going to have to sell, or whatever this thing is we're selling, in order to actually break even. So pretty simply, you're going to get all the x's to one side, so we'll subtract 400x on both sides, and we get 500,000 equals 200x. And then I'm going to divide both sides by 200. No, I am not doing this in my head. I actually have it written down. This is 2,500. So basically what that's telling me is I need to sell 2,500 units of whatever this thing is to break even. So I have not lost money now. I haven't made any money. So once I sell 2,501 units, I'm actually now starting to make money. So that's the idea. X is the amount that you would have to sell to break even.